In this short video, we'll take a look at using Vantiq to take in real-time inferences from an AI engine from computer vision to identify situations of interest or situational awareness and take various kinds of actions. So here in the back end, you're looking at the application. The stream service is the service that takes in the real-time information, the streams of information, converts them into a common format, and it passes those over to a camera service and an observation service. The camera service is designed to do some really simple things. One is to automatically register the camera. So each camera could be talking, 30, 40, 50 inferences per second. And so what this does is in memory looks to see if it's ever seen that camera before. If it's never seen the camera, then it registers it for the first time, and it appears in the dashboard as a registered camera. It also keeps track of camera status. Once there are inferences going through and a camera has been identified, it will look to see if that camera goes missing. And if it does, once again, it will update and has the potential option of notifying the correct individuals that the camera is down or offline. The other part of the system, of course, is the observation service. The observation service is designed to look at what's going on in those streams of data, in those inferences, and when those conditions are met is to call various custom actions, as well as, based on what the observation service is seeing, inform a web client. You can see in the observation service, it basically does some calculations of whether things are in or out of a certain zone, whether they dwell in those zones for periods of time, as well as do this GPS conversion, which is to take the XY coordinates from the inference engine and actually turn them into geospatial information on a map so that we know the exact location of those events. So let's take a look at our web client, also built in Vantiq with Vantiq's Client Builder, which basically onboards each of those cameras and allows us to configure them. So here you can see on the second line, we have a camera that is registered. So this would be a new camera that the system has never seen before, puts it in a registered state. Once you have inside that registered state, you can come inside the application and you can provide some supplemental information. So I could say this is 10 Main Street and I don't know, Brockton, Massachusetts. And we'll see that it updates. We can fine-tune the camera's actual location. We can give the camera a name, as well as the calculation for what we want that camera for. When we're looking at those inferences, we're looking at calculating things that are in the zone or not, whether or not we're using centroid calculation, the center of the identification, or even the bottom center. This is more useful for tracking people and objects so that you're looking at the feet position of those kinds of things. Also, the ability to upload a background image. And once you've gone ahead and you've done that, then you are actually looking at the registered online versions of those cameras. Of course, we can also see cameras that are considered to be offline. Again, that's a visual representation letting us know that something is wrong with the system, something is not actually happening. When you do have the cameras, once they've been registered and they've gone into their online state, you can start editing zone information. Here, what you're seeing is the real-time inferences coming into the system. They're being painted on the background image that was uploaded. This is an actual live view of some cameras. And we can see the cars that are crossing the intersection. This one's clearly waiting at the light here, probably cross in a moment. The box in the middle is the bounding area that we can basically configure for what is inside. In fact, you'll notice that whenever you see a car or a vehicle or something inside the bounding box, that it turns red. That doesn't necessarily mean anything's wrong, because each one of these is also given a unique ID. What we watch for is, again, that dwell time. Is something sitting in, at least in this use case, is something sitting in the intersection for more than a specified amount of time? So if some individual ID is sitting there for more than 30 seconds at a time, then we'll raise an alert from the observation service over to the custom action service or to an issue service of some kind to send notifications, whatever the use case dictates for. Send to first responder. And when you're sending information to people about where these events are actually occurring, it's important to know the actual location. So the other thing that we're able to do is take the GPS location of those things. So for example, you can see that each vehicle in the upper quadrant here is also being converted into a 2D spherical GPS coordinate position, so that when we send a first responder, we send somebody a notification that there's something going on that we have to pay attention to, we are sending an exact GPS referenceable location so we know exactly where to go. Anyway, this has been a very quick demonstration of an application that was put together in just a couple of days that allows us to take in real-time inferences from AI engines into the Vantiq runtime and provide situational awareness, alerting, and any kind of custom action. This is designed to be used with any inference engine, so it really doesn't matter which one, so long as we can get a payload that describes what's going on. We convert it into or normalize it into a common format, and then perform all of our calculations. There's one additional feature, which is when you are doing unique ID tracking, we're also able to track the status of items. And so we can see that in a given location, what the overall traffic patterns are. And you can see from a day-to-day basis that the traffic patterns are fairly consistent. We can see what times of the day we are busiest. This could inform us as to when we might want to put more security or more resources of a given kind, again, depending on the use case, triage it to those locations when necessary, based on hours of the day and common traffic patterns. So I'll stop the demonstration here. Thanks for watching.